Now you must be knowing to define position of a point in a plane. We divide plane in 4 quadrants using 2 reference lines, horizontal line and a vertical line. So here that horizontal reference line x-axis, and here that is vertical reference line, that is y-axis. Intersection of xy axis is origin, a fixed reference point you can say. And with reference to xy axis or with reference to origin, we define 4 quadrants, 4 parts of the plane as 4 quadrants. Now here is point A in first quadrant. What does that mean? It is on the right side of y-axis and above x-axis. Then using distances, we define its position in this manner. We say that point is 40 millimeters on the right side of y-axis and 30 millimeters above x-axis. What does that mean? Point is in first quadrant. Similarly, on the left side of y-axis and above x-axis, that is second quadrant, below x-axis, left side of y-axis, that is third quadrant, and here it is fourth quadrants on the right side of y-axis and below x-axis. Exactly in this manner, in engineering drawing or engineering graphics, we divide space in 4 quadrants. Now this is how we divide it in 4 quadrants. We use a vertical reference plane and a horizontal reference plane. The line of intersection of vertical reference plane and horizontal reference plane is xy line. Now in drawing or in engineering graphics, xy line are not 2 different lines, it is one single line, remember. Now vertical reference plane, we refer it as VP, and horizontal reference plane, we refer it as HP. In some books, these 2 terms are used for VP and HP as FRP and HRP. FRP means a frontal reference plane, nothing but vertical reference plane. HRP is horizontal reference plane. But of course, in this engineering graphics video series, we are going to use these terms, VP and HP. Now, fundamental position of an observer is considered in front of VP and watching an object in the direction perpendicular to VP. So this is how we always imagine that observer is watching an object in the direction perpendicular to VP, and this is fundamental position. But actually observer can watch an object in infinite directions. He may watch it from top, from right side, from left side, or at an angle 30 degrees with HP and VP. It all depends. So observer can change his position for different views of the object, but what I said, fundamental position of observer is always considered in front of a VP, watching an object in the direction perpendicular to VP, and the other positions of observers are called auxiliary positions. Now, with reference to this position of observer, the portion of space in front of VP and above HP, in front of VP and above HP, that portion of space is considered as first quadrant. The portion of space behind VP and above HP, behind VP and above HP, that portion of space is considered as second quadrant. Portion of space behind VP and below HP, behind VP and below HP, this portion of space is considered as third quadrant. And portion of space in front of VP and below HP, in front of VP and below HP, this portion of space is considered as fourth quadrant. So remember these things now. In front of VP above HP, that is first quadrant. Behind VP and above HP, that is second quadrant. Behind VP and below HP, that is third quadrant. And in front of VP and below HP, it is fourth quadrant. Now let's focus on only first quadrant. Here is a point. Of course, a point is infinitesimally small object. But in this diagram, I have exaggerated its size to just make you visualize the point in first quadrant. Okay, here is a point in first quadrant. Let's label that point as point A. So we'll say that point A is in first quadrant. What does that mean? It is in front of VP and above HP. So it is 40 millimeters in front of VP and 30 millimeters above HP. So the observer is watching this object in the direction perpendicular to VP, and whatever he can see, that means this point, he draws exactly behind the object on VP, and that is its front view. It is also called projection of point A on VP. Now this front view we are labeling in this manner, A dash. Now point is A, which is labeled with capital letter A, but its front view is labeled with small letter a. Now when an observer observes the object in the direction perpendicular to HP, and whatever he can see, if he draws exactly below the point on HP, then that is its top view. It is also called projection of point A on HP. Here we are labeling this projection as letter A, but remember it is small letter a. So watch here, this point which is in HP, don't say that this is point A, you should say it is top view of point A, and here it is front view of point A. So view in front view, so view in VP is front view and view in HP is top view. In other words, projection on VP is front view and projection on HP is top view. Now listen, what is distance of point A from HP? 30 millimeters. Point A is 30 millimeters above HP, and that 30 millimeter distance also appears in VP in this manner. Distance of A dash from XY line is 30 millimeters. So we say that front view gives a distance from HP. Front view gives distance from HP. Now what is distance of point A from VP? 40 millimeters. This 40 millimeter distance appear in HP also. Watch here. Point A is 40 millimeters from VP. Now watch its top view. Top view is 40 millimeters from XY line. So we say that top view gives a distance from VP. So front view gives distance from HP and top view gives distance from VP. These two statements are very important in engineering drawing. Front view gives a distance from HP and top view gives a distance from VP. Now one interesting thing, front view is view in VP and top view is view in HP. So front view and top view of an object are always in two different planes which are perpendicular to each other. But in reality, we draw front view and top view on one single plane. And what is that plane? It is plane of our drawing paper. So how is it possible? How VP and HP appear in one single plane? So try to understand this. We always imagine that first and third quadrants are opened and second and fourth quadrants are closed. To bring views in one single plane of drawing paper, we consider that HP and VP are hinged at XY line and they can rotate with respect to each other about XY line. So here imagine that along XY line there are hinges so that these two planes can move with respect to each other. These two planes can rotate with respect to each other. And now imagine rotation of HP, horizontal reference plane, about XY line. And how the HP rotates? So that first quadrant opens and fourth quadrant gets closed. Third quadrant gets opened and second quadrant gets closed. And this is how you get both these planes in one single plane. Imagine closing of second and fourth quadrant and opening of first and third quadrant, and you will find that HP and VP, both the reference plane, overlap each other. and that becomes a plane of our drawing paper. So you will understand it better. Watch here. Point A is in first quadrant, and as I told you, first quadrant is imagined to be opened. So we'll open that first quadrant. So rotate this portion of HP about XY line so that HP moves and comes in the plane of VP. So this is how now HP is in the plane of VP. So of course, whatever drawing is there on HP now will appear below XY line. So this 40 millimeter long line is now below XY line. This point A, now remember, this is not point A is here, and this is top view of point A. So this top view of point A will appear here below XY line. This 40 millimeter distance now will appear below XY line. So whatever there I have written on HP, say HP here in bracket HRP or this top view, everything is here now below XY line, and now VP, portion of VP and portion of HP are in one single plane, and that is a plane of our drawing paper. This is three-dimensional diagram. So let's draw two-dimensional diagram of our drawing paper. So now this is our drawing paper, and on drawing paper here it is XY line. What is XY line? Line of intersection of HP and VP. Front view is now above XY line, and it is 30 millimeters above XY line. As I told you, front view gives distance from HP. So front view is 30 millimeters above XY line, and that is what we can see here. And top view is 40 millimeters below XY line. Now we should use these instead of below XY line, we'll say in front of XY line, because top view gives distance from VP, and instead of from VP we should describe position of point precisely. So we should not say that from VP, we should say it is 40 millimeters in front of VP. Instead of from VP we should say in front of VP, so it will be very clear. Okay, so point A is in front of VP, and here it is top view. So this is how front view and top view appear in plane of our drawing paper. Now watch here, as I told you, first quadrant to be opened. Similarly, third quadrant also we imagine opened. So if a point is in third quadrant, then its view in HP, its projection on HP is top view, and its projection on VP is front view. So now point, if it is in third quadrant, its projection on VP will appear below XY line, and it is projection on HP when you open that third quadrant will move above XY line. So if point is in third quadrant, top view moves above XY line. So here I have shown drawing of a point that is in the third quadrant. Now listen, nowhere in this three-dimensional diagram I have shown that point B in third quadrant, but you are watching a drawing, and what it is, top view of point B is above XY line and front view of point B is below XY line. Front view is always labeled with a dash. So this is very important to remember now. Two views of a point are labeled, front view and top view of a point are labeled with small letters. And to differentiate front view and top view, we use a dash for front view. Remember. Okay, so here it is front view and top view. So watch here, in this diagram, front view is above XY line, and in this diagram, top view is above XY line. So when front view is above XY line, you are sure that point is in first quadrant, and when top view is above XY line, you are sure that point is in third quadrant. Also, top view gives distance from VP and front view gives distance from HP. So nowhere I have shown that point B in this three-dimensional diagram. Still from this diagram you know that point B is 25 millimeters below HP. Do you remember what I told you? That front view gives distance from HP and top view gives distance from VP. So watch here. Here it is a front view. So this is distance from HP, 25 millimeters. So point B is 25 millimeters from HP and 20 millimeters behind VP. Point B is 25 millimeters. Now when I say point B, remember this is not point B, this is top view of point B, and here it is front view of point B. Then where is point B? So from this drawing, that point B is 25 millimeters below HP. Remember it is front view, and front view gives distance from HP. Not only the distance, whether the point is above HP or below HP. That also you know from front view. Remember, therefore we use this statement. Front view gives details, not just distance. We will say front view gives details with respect to HP. Details means details of position of point. Front view gives details with respect to HP. So if I ask you, where is point B with respect to HP? Then on drawing paper, just focus on front view, because front view will give you those details. And if I ask you whether point B is behind VP or in front of VP, focus on top view of point B, because that top view gives details with respect to VP. So watch here, point B is 20 millimeters behind VP. Remember, this portion of HP is in front of VP. Watch here, this portion of HP is in front of VP. So when you open the first quadrant, HP is here. So this portion is in front of VP and this portion is behind VP. When you talk about details with respect to VP, we use these words, in front of VP and behind VP. So if I ask you whether point is in front of VP or behind VP, then on drawing paper, with respect to XY line, this side is in front of VP and this side is behind VP. And if I ask you whether a point is above HP or below HP, then watch here, this position or this portion of drawing paper is above HP and this portion of drawing paper is below HP. So it's that simple. Above HP, below HP means on drawing paper above XY line, below XY line. Simple. And in front of VP and behind VP, to use the same words with reference to XY line. So behind VP means on drawing paper behind XY line. And in front of VP means on drawing paper it is in front of XY line. So this position, this is in front of XY line and here it is behind XY line. Okay, so what is position of point B with respect to VP? So watch top view. Top view gives details with respect to VP and you should say that point B is 20 millimeters behind VP. What is position of point B with respect to HP? So watch front view and you should say it is 25 millimeters below HP. Now distance from HP, distance from VP on drawing paper, it is distance from XY line. So how important XY line is on drawing paper? Have you understood that? So whatever I ask you with reference to HP, you focus on front view. And whatever I ask you with respect to VP, you focus on top view. Now watch here. So second quadrant. Here it is point. Let's label that point as point C. It is in second quadrant. It is 40 millimeters behind VP and 15 millimeters above HP. So point C is in second quadrant. It is 40 millimeters behind VP and 15 millimeters above HP. That is what you can see in this diagram. Now projection of point C on VP. Projection of point C on VP is front view. And projection of point C on HP, that is its top view. So top view to be labeled without dash with small letter. So C is top view, C dash in front view. Now what is distance of point C which is in second quadrant from HP? So 15 millimeters. Now that 15 millimeter distance front view gives on VP. So point C is 15 millimeters from XY line. Point C is 15 millimeters above HP. So here front view is 15 millimeters above XY line. And that is why we say that front view gives details with respect to HP. Now point C is 40 millimeters behind VP. So watch here, top view of point C. Point C is 40 millimeters behind VP. So watch here, top view of point C is 40 millimeters behind XY line. So we say that top view gives details with respect to VP. Now how you are going to draw front view and top view in plane of our drawing paper, because these two views are on two different planes. So now you know it, that is second quadrant is to be closed. What here, HP moves above XY line. So all details, all drawings in HP will move above XY line, and front view is already above XY line. So both views you get above XY line. So this is your drawing paper. Check here C and C dash. Top view and front view of point C both are above XY line. Now front view gives distance from HP. So what is distance of point C from HP? 15 millimeters above HP. Point C is this point C we are talking about. From drawing it is clear that point C is 15 millimeters above HP, and it is 15 plus 25, that is 40 millimeters. So point C is 40 millimeters behind VP. As I told you, that is this portion is in front of VP and this portion is behind VP. Now even if three-dimensional diagram is not in front of you, you can identify positions of point from drawing, and that is called reading of drawing. Point A is in first quadrant, point B is in third quadrant, and point C is in second quadrant. How come? So simple. An engineer knows that front view above XY line, that means point is in first quadrant. Here it is top view is above XY line, means top view, that means point B is in third quadrant. Here both views are above XY line, means point is in second quadrant. Similarly, if point is in fourth quadrant, you will get both of its views below XY line. So remember these points. What we have studied up till now, listen. XY line is line of intersection of HP and VP. So XY line, and it's always very important to label XY line. A projector is a line perpendicular to XY line. Now if there is a horizontal line on a drawing paper labeled as XY line, how many lines perpendicular to XY line you will able to draw? So of course infinite. So there can be infinite projectors on drawing paper. But we identify projectors in this manner. Watch here. This line, is it perpendicular to XY line? Yes. So it is a projector according to this statement. So we say that this is a projector of point A. This is a projector of point B. This is projector of point C. Projector of point A means the vertical line on which A and A dash are. That means front view and top view of R. The vertical line on which B and B dash are, that is projector of point B. So this is projector of point C. So on drawing paper, front view and top view of a point lie on single projector. Remember, on a vertical line, front view of point A, and on any other vertical line, top view of point A. That is impossible. Two views means front view and top view of a point lie on single projector. Remember, if point Q is in the space, then on drawing paper its front view is labeled as Q dash and top view is labeled as Q. So it means if point is a B in space on drawing paper, then its front view is labeled as B dash and top view is labeled as B. Remember, we use small letters to label front view, top view, and not only that, we use dash to differentiate front view. So front view above XY line, that means first quadrant. Top view above XY line, so point is in third quadrant. Both the views above XY line, that is second quadrant, and both the views below XY line, that is fourth quadrant. So here, check here, front view above XY line, only front view is above XY line. So that means point A is in first quadrant. Top view above XY line, watch here, only top view is above XY line. So point is in third quadrant, here point B is in the third quadrant. This is not point B, this is top view of point B. Point B is in third quadrant. Both the views above XY line, second quadrant, and both views if are below XY line, that is fourth quadrant. Now to remember, check here. Here I have used red color for letter F. Same way here I have used a red color for letter F. So focus on letter F. Front view above means the first quadrant. To remember this, take help of letter F. So front view above first quadrant, top view above third quadrant. Remember this. Front view gives details with respect to HP and top view gives details with respect to VP. Of course, these efforts you will have to take initially only, because after some practice you will remember it. It's not difficult. Front view above first quadrant, but initially to remember this, take help of letter F. So front view above first quadrant, top view above third quadrant, take help of letter T to remember this. Top view, third quadrant, top view above third quadrant. And it will be easier to remember other two quadrants, both views above second and both views below fourth quadrant. Okay, we'll meet in our next video. Thank you.